Hello everyone. Today I will be talking on tracking storms using radar data. Convective storms, which are responsible for high impact weather such as flash floods or high thunderstorm winds, cause huge risk to properties or human life. Now, in context of managing such crises, warning can be really improved through nowcasting, which uses radar as primary tool. So, tracking storms plays a very important role in overall operational applications. So that's why I was so interested for this project. I'll be sharing four objectives for this presentation. Why to use tracking algorithm, how to track a storm in radar image, what are the different approaches, and how these approaches impact performance of an algorithm. Now in US, there are 158 next generation site for WSR88D, which provide two types of data, base data and derived data. Image shown on the right shows the typical flow at NWS, which basically processes data in different units. So RDA is basically radar data acquisition, and RPG is radar product generator. Radar product generator uses base data from RDA to process with this SKIT algorithm to give the data in STI product and other algorithms. So SKIT is basically storm cell identification and tracking algorithm. So SKIT is useful because it not only provides data to other algorithm but also gives direct data which are being used by direct users for warnings and other decisions. So how does it look like? Like how a storm cell identification and tracking algorithm works? So there are two steps: cell identification and tracking, which is so cell identification is basically identifying storm in current or one radar scan, and tracking is basically motion of this storm by identifying same object in successive scan. Now let's understand these two steps in a little more detailed manner. First of all, this is an example of SKIT algorithm which is being used at NWS. So algorithm first identify a one dimensional segment. Image shown in the right shows one dimensional radial reflectivity data. So algorithm uses two adaptable parameters such as reflectivity threshold and size bin. So it identifies segment while looking at each range bin down radial until it encounters an out of range bin. So for example, for 30 dBz, this will be identified as segment, and for 50 dBz, this red box will be identified as one segment. So now once the segment are done, which are oriented, the segments basically are oriented radially, so they are combined to adjacent segment to form a two-dimensional object called component, as figure shown in the right. Once all the components are defined for each elevation slice, these components at each tilt are combined to form a cell. Now, centroid of this cell is estimated by combining these components based on the weighted correlation of their reflectivity at their center of mass. So cell is the key because it will be used to characterize storm motion and even locate the future location of the storm. Now, overall output of this SKIT algorithm is being used in tracking algorithm where so this is an example of the output of a tracking algorithm. Image shown in the left shows the cross-sectional view and the Lagrangian view, which is the time, which is the reflectivity over the period of time of one cell. And image shown on the right shows the scan-wise cell motion. So we can see the overall area, the location, and the volume, and the maximum reflectivity over the period of time. So this is basically the kind of tracking information we get from a tracking algorithm. So now TINT and SKIT. So far I have discussed these two tracking algorithms. But can there be different approaches for tracking algorithm? Yes. So Lakshman et al. Evaluated these 5 different techniques and created his own techniques. So we'll discuss each of these techniques one by one. Projection method, as its name suggests, based on the projection of the based on the projection of the new cell based on the projection of the previous history of the cell. So here a new cell is identified if a new cell is identified based on the linear least square fit of the previous motion of the stromes. So we can consider this is a centroid based approach, and it usually gives linear tracks. So it basically assumes linearity in tracks. So age-based method is a modified version of projection method. So of course it uses projection-based method, and here the priority is given to the longest track history of the cell. So I mean, if the cell is having the more longevity based on the track history, then that cell will be preferred over a different cell. So these two approaches are called centroid based approach. Now optimization approach is based on optimization of certain criteria. Here that criteria is global cost function, which is nothing but the weighted sum of position error and volume inconsistency error. So volume consistency error for all possible paths. So for all possible paths, this global cost function will be calculated, and based on the minimum global cost function, the path will be chosen. So the path is used based on this optimization approach. Whereas overlap method is based on identifying cell based on the maximum overlap between two cell, which is like unassigned cell with the previous cell. So here the priority of overlap is given to the largest cell and then to smaller cell. So in this manner you can see like it preserve the size and have more consistency of strome attributes between tracked cell. Now a third kind of criteria is basically enhancement approach. So one method was used by Hen et al in 2009, which is the combination of optimization and overlap method called OC method, which is also used in enhancing the existing Titan algorithm. By the way, optimization method is used in Titan technique, and projection method is being used in SKIT algorithm. They are like operational tracking algorithm. And so like let's talk now. We were talking about new method. New method is being generated by it's created by Lakshman et al in 2010, and which utilize all of these methods. So basically the best feature of all of these methods are utilized at different steps in new algorithm. Now we have different approaches of these algorithms now. So but which is like, how do we evaluate the performance of these algorithm? So that depends on the method of evaluation. So for example, this track is being generated by one of these algorithm, and how will you evaluate this track? So of course, one example of evaluation on one method of evaluation is indirect method, where you will compare this track with the observed one and you will see how good and bad it is, right? But this kind of method has a problem, because algorithm, I mean, we cannot capture the real error in algorithm, because strome may evolve, like it can split, merge, or decay, and that cannot be captured by algorithm. Or there can be real issue in the algorithm, like the position error is just because the algorithm concept was not correct, right? So in order to deal with this problem, there is a direct method. Direct method is based on the percentage of correct association. This method will be compared with the track which is being identified by a human. So like human can better capture the overall association just by like seeing the pictures. Of course it is labor intensive, but that human track could be compared with the track to understand the performance of this algorithm. But this type of method also has problem. For example, so if we understand this, like this black solid line shows the correct association and dotted line shows the incorrect association. So this 9 out of 10 association are correct. So in this method we will give it 97% of the skill. But is it correct? Because after T4, track could go anywhere, like it could jump, it could go down, it could go straight. So we really don't know what was the track after T4. So giving it 97% of a skill may not be worth. So for that, Lakshman et al. Thought of evaluating it on duration criteria, where you just evaluate this track based on the correct duration. Like, so the track was correct for 50% of duration of its track history, and it was completely different, or we don't know it's I mean the duration after first half. So based on duration criteria, the correct skill would be 50%, which is reduced now. The second problem was non-specificity. Like, we don't know, I mean, even if it is giving 97% of skill, but we don't know like what are the real issues which are hidden behind this skill. So because it could go in a different direction. For example, there could be a different evolution of this track. For example, dropped association is one where track could go down, and of course this can be resolved by measuring this using duration criteria, where you just understand how correct like how long the track was correct based on its based on its criteria. Now, second kind of example is where you see mismatch error. So like track could go in a completely different direction. So here, of course, if we observe the consistency of Strom attributes from like the previous cell, it will be completely different, because now Strom is in completely different direction. So of course this has problem with the consistency of Strom attributes such as VIL. So I mean this is a second criteria of evaluation. Third is jump in association. It's like if the track is completely jumping off, of course it will have issues with linearity. So in order to see the real issues with each of these criterias, we need to have three different statistics which can observe the error in these three different criterias. So he got different cases for like different Strom types, and calculated the error for all of these criterias, and came up with the statistics called VIL error, linearity error, or median duration. So you can see here the black bar shows the good technique, basically good skill. White shows worst technique, and gray shows not so good, but yeah, better. So I just categorize them in a table with the colors so that we can see it clearly. So what's happening here is projection method seems best, and edge-based method based better in consistency and linearity. CST and OC method are worst in consistency and linearity, but best in duration. Overlap method is also following the similar kind of thing as projection and edge-based method, but it is also worse as projection method. Here, H and new method, which are enhancement of the previous technique, are basically seems to have a better performance than other methods. Now, here you can see CST and OLC method, which are optimization method. So you can see that the same criteria, like for same type of a Strom, the same criteria can have different performances of the scheme. Even in the same criteria, you can have different performances of the scheme. So I want to also show you, I don't want to end here, I just want to show you this is the metrics for different Strom types, and you can see how complex it is. But there is something which we can really understand from this matrix, is that all the schemes are not bad and all the schemes are not good. So if you want to analyze it for a specific type of a Strom, we really have to understand this matrix so that we can come up with a better technique for tracking the algorithm for that specific type of Strom. Now, I hope you have a better idea of tracking algorithm now, and I have a quiz for you. There are basically 4 questions. I'll share those questions, the link of this survey with you over Slack. Thank you so much, and thank you so much for listening till the end.